Hi everyone. My name is Pavel Shigelski, and it's really challenging to pronounce my surname in English. Even in Russian, it's a problem. But yeah, today we are not here to talk about my surname, but we're here to listen to our excellent speakers. And I want to say hello to everyone on the opposite side of the monitor who is watching us, who is joining our stream. Hi community, hi audience. Okay, GDG Minsk continues the tradition with online meetups, and before we move forward, I want to get acquainted with you and introduce a bit what GDG Minsk is. I'm very excited today, and would you mind if you wrote in the chat where you're from and say hello to your virtual neighbors? While you're replying, let me answer what GDG Minsk is and who we are and where we are from. We are a Google Developers Group, and it's a community located in Belarus, in Minsk. The main goal of the community is, of course, networking, sharing knowledge and experience, talking about different technologies, not even necessarily about Google technologies, even if if our community called Google Developers Group. And of course, meeting new people, expanding our social network and interaction. We do meetups and conferences as well, but usually we focus on three main streams. It's web, cloud, and mobile. So if you're interested in those subjects, you will always find something interesting at our meetups. How can you find GDG Minsk and join our community? Basically, we are everywhere in all popular social networks like Facebook, like Telegram, and of course YouTube and Twitter. And I highly encourage you to check our YouTube channel for previous meetups. You will find there so many different topics. I hope that you will find something interesting and very informative for you, very nice for you. And of course we are online. That means that basically you can face some problems, some internet problems or any other problems, connection problems. Don't worry, we can help you there. Please contact us in the chat so we can help you there. Last but not least, we need your feedback, of course, to improve our meetups, to improve our stream. And every feedback helps us to move forward. So we kindly ask you to leave feedback after our meetup, because everything we do is for the community. Okay, that was a short intro about GDG Minsk. I hope that you find something useful for you and you get acquainted with what does mean GDG and what does mean GDG Minsk and who we are. And today we're going to have two presentations. Both speakers will present in English and both speakers will talk about security. It's really a combo today. And I'm really excited to hear the stories, to listen to the stories. And now we are ready to welcome our first speaker on the stage. Hi Camille, how are you?
Hello everybody, glad to be here. I'm well, and you?
Yeah, good. Thank you. What do you do on daily basis? Why do you like Formula One? I noticed that in your short bio that you like Formula One, and it's really interesting. Why do you like it, and who's the best?
All right, it's a good question. I think my story with Formula One started somewhere around 2007, maybe a little bit before. When Robert Kubica, I think the only Polish driver, was part of Formula One and was becoming this prominent star alongside Lewis Hamilton at the time. I'm originally from Poland, currently live in UK, but Poland is in my heart. So being a fan of a Polish driver in Formula One was the thing that brought me in. Robert is still somehow in Formula One. He had bad luck and bad accident in the past. I think he had good spell last year or 2 years behind when he was a driver for Williams. Now he's still fighting to kind of come back to Formula One. So finger crossed that's going to happen. But yeah, that's the story about Formula One and why I like it so much. So
Yeah.
Hopefully,
Great,
we will
great.
see Robert again.
Me too. I'm not keen on Formula One, really. Sorry, but yeah, I can understand what you're talking about. Good. Okay, so then I don't want our audience to wait any longer. So maybe we can start our first presentation. Uh,
Awesome.
Let me share. Yeah, can you share the screen? Can you share your screen, and we'll start
Let's
with
do it. And can you see my screen now?
Yeah.
Awesome.
Yeah.
I'm just going to click present. And here we are.
Yeah. So I will leave the stage and will wish you good luck and rock the stage. Then everything is yours. No.
Perfect. Thank you. Hello again, everybody. Thank you for having me in your meetup. My name is Camille. This talk is going to be about unifying security testing between kind of security engineering requirements and to make sure that kind of developer experience it's there in that pair. This is going to be kind of side story of what Open Policy Agent is in action, and we're going to get into the details. Disclaimer, I'm not here to represent the company I'm working on at the moment, so opinions here are only my own. And I do work for a commercial product that is related to the topics in this conversation, so just bear that in mind. So who am I? My name is Camille, like you know. I am security engineer by profession. My background is initially in offensive security. So I was a pentester, hacker, a security researcher, and analyst for around 5 to 6 years, mainly focusing on testing security infrastructure in cloud environments. So anything around AWS, Kubernetes, Openstack was kind of my passion. After spending some of the time kind of breaking into the systems and I kind of built up this passion towards these cloud technologies and wanted to become an engineer on the side of developing these systems. So I moved to become a cloud engineer to build kind of security controls and help protect these instead of breaking them. And currently I'm working for Snyk. Snyk is a security company that provides various products from open source security to cloud. And I work on the infrastructure as cloud product. So let's get started. Kind of, if we look from security point of view, our kind of North Star and objectives are to prevent misconfiguration in cloud environments. This talk is going to revolve around examples in Kubernetes as an example of kind of cloud environment, but we're going to touch on how that impacts things such as AWS or GCP as well. And what we want to do is to make sure that we enforce the kind of security policies or practices we want to ensure on all of the entry points. So from my background in offensive security, I kind of spent many years trying to look around the loopholes in the systems where we can find different way we can circumvent controls. So the North Star is that there isn't such paths where we can circumvent these decisions. And kind of the third big topic is we want to audit and any attempts to circumvent those controls. So as I was a pen tester for many years, there was a kind of a blue team on the other side, which being the people who monitor the systems for security intrusions, who try to attribute my behavior to certain things that I was doing. So from a North Star, we want to be able to prevent all of those things. And here in an example, you can see that we can use things such as kube control on a kind of CLI console to connect to a cluster. We can do that through pipelines such as Argo CD is a system that allows you to deploy dynamically things to the cluster with your configuration that's stored in a Git. And you can do this through cloud consoles as well. So when we're looking at it from kind of engineering point of view, the first idea that comes to mind is to block bad config in API. Logically speaking, if we can prevent this at the API layer, we can, on the server side, we can ensure that any and all API calls to that endpoint will be protected with the same policies. So as long as there isn't a vulnerability in the API itself, we can ensure that the bad configuration that we try to kind of push to the cluster will be prevented. So in Kubernetes world, we can introduce something called admission controllers. Admission controllers are basically webhooks that sit alongside API servers that validate requests based on certain criteria. So whenever you think about sending a request to an API server in Kubernetes, that API has a certain parameters. So if you want to deploy a pod or deployment specification, it will have certain features. It will say, for example, if the pod can run with privileged permissions, or if the pod can be running with UID 1000. And we can check for these things. We can have admission controller that listens to all of those requests, and whenever the request comes in, it validates our policies. We can write a policy that says the pod cannot be privileged. We check that, and if the admission controller defines that this request has the privileged pod, it says a deny to the API server, which then kind of rejects the request. So in order to show that in action, I have a demo environment over here. Hopefully you can see my font size. As you can see here, we have no pods in this simple cluster. But let's go and what can we do? In here, I have an example of container that wants to run with privileged permissions. So as we can see here, there is a flag that says privilege true. And my Kubernetes cluster was configured with admission controller, and we get into details in a second what that admission controller is. And then we're gonna just try to deploy it. And then if everything works as expected, what you can see here is that we get a kind of deny message that says container must not run as privileged. This was prevented with admission controller. When we on a kind of console level access, this is quite fast feedback. So problem solved, right? So if we can do this, then everything is well and good. Well, let's see this in true action, right? So in production systems, you usually won't be deploying pods directly to the cluster, right? So in my example, I have a simple application. It's a Golang application that is deployed with Helm to Kubernetes cluster, and there is a Docker file that builds it. So let's try and change that configuration. So I have my configuration here. What we're going to do is going to just try to set it to true. I'm going to commit it. In this example, I'm going to commit it directly to my kind of release branch. Usually you should have kind of PR checks, but we're going to get to that in a second, how that works. Attempt privileged pod. And always sign your commit. So that's why I need to enter my long password. I'm just going to push it. Demo application. And what we should see here in a second, that our pipeline has been triggered. Now, what this is going to do is we made a change. It's going to take a certain amount of time to go through all these steps. And these steps are build a container, validate that the code that we've written is correct, push it to ECR registry, and then notify our kind of application that something has to change. Argo CD monitors the repository at the same time, but we're going to let the pipeline finish its job and notify it to update itself. It should take a minute-ish. While we're waiting, last time I ran this, it took around 3 minutes. But what you can see here is that the pipeline failed. We had the kind of admission controller prevent our access, and as you can see here, we get the same message that we got in the console, but in a PR. Now, this takes around 3 minutes-ish. In our production systems, our pipelines take from 5 to 10 minutes. They still consider fairly fast in terms of kind of deployment times. I've seen production systems that take 30 minutes to go from when you submitted the API, it got approved and pushed. That is a very long delay between you making a change and getting kind of feedback that there is a potential misconfiguration that you're trying to do. Let's see if this is finished now. It's still building. So you see, we still have to wait to find out that something is going to be wrong. So problem is not really solved. Developers do not want to wait that long, and we as security engineers should not expect them to wait that long. So what can we do about this, right? So blocking API calls is frustrating to the callers. If you didn't know that someone has set up these kind of policies, that's even worse. It would be very surprising to you that you've pushed a fix to a breaking change, only to find out that at the end that the cluster has declined your new system to be deployed. So enter Open Policy Agent ecosystem. What is Open Policy Agent? It's a kind of collection of tools that allow you to write policies, whether these are security policies or kind of admission policies, authorization policies. They could be also linters. It's just up to you what you want to define as a policy in a kind of declarative way that has some functionality similar to policy, to kind of imperative language, but it allows you to focus on writing a policy logic and not thinking about, am I using correct sorting algorithm, or is my code efficient, or do I have infinite loops in my policy logic, which means my kind of admission controller will just be stuck in a loop trying to kind of understand what's policy doing, but there is just a bug in the logic, right? So that's why you want to use something like Rego. Rego is a language based off Datalog. It's not very well-known kind of language, but it's there to allow you to query structured data for specific logic purposes. Let's see if our pipeline has finally decided to tell us that it's finished. Still doing it. So demo gods are not with us today, but we can continue. What we saw so far is that we implemented something called Gatekeeper in our Kubernetes cluster. And it ended up at this end side of the story to enforce. This can often be implemented by security teams to make sure that we don't have misconfigurations. It's powered by Open Policy Agent. It's all of the policies that we apply are written in Rego, and we're going to see examples of them in a second. But the ecosystem allows us to move kind of left and all the way left to developer and the local CLI, and we're going to see that in action. In order to run CLI tools on Rego policies, we can use a tool called conftest. Conftest is just a CLI tool that executes Rego against your configuration files. In order to help you develop these policies, there is good ecosystems of tools that allow you to debug these rules, show you what's going on. The language, when you start using it in the first place, might not be very user-friendly, I would say. But it's the kind of user-friendliness, it's there to prevent you shooting yourself in the foot. So for example, you cannot do things such as recursive functions in Rego, just to make sure that your policy evaluation always ends. And finally, when you write these policies and validate them, you want to share them, and you want to share them between people, but you also want to share them between systems. So there is an amazing tool called Constraint that allows you to use single source of truth, such as Rego source code, and kind of template it into both the rules that can be used by Conftest and CRDs, custom resource definitions, which what a gatekeeper is using to kind of enforce things in the cluster. So let's get into some of the examples. Demagos are really not with us today. We want to write a rules once. So this is example of a Rego policy. When you first time look at it, you might feel like it's a programming language, right? So there are packages which namespace your kind of logic into a package. You have imports, which means you can have composable code. You can have libraries that you can reuse pieces of that code. And there's something called rules, which are these statements. However, that's where the kind of language familiarities from other imperative languages such as Golang or Python kind of stop. When you see things such as functions with the same names, these implement kind of additive statements, meaning, or you could think about them, they implement kind of an or operation. In this example, what we want to express is that container is privileged is if either of these two cases are true. And then you can just call it once, and they kind of make up an if-else statement. And then within the rules, all of these operations are an AND operation. So all of these statements inside of here need to evaluate to true for us to get a positive feedback. There is way more to Rego as a language, so I will not go into details because we don't have that much time, but I would really like you to just go to the open source repositories and browse and see how that works. So we want to write it once. And then what we want to do, we want to generate these policies so that they can be reused by multiple things. And here we can use tool constraint to create all of these policies. So in our example, what we did, we have this one policy called the one that we saw in the example before. We write just one. We use the constraint tool to generate these CRDs, which look like this. If you're not familiar with Kubernetes, these are kind of very detailed. They operate such like Kubernetes objects, but they defined new types. And inside of them, what you can find here is the same source code that we saw in the source file that can be shared and reused by Kubernetes Gatekeeper. So that's how we generate them. And then we want to share them as code. So we want to reuse the principles that developers have been using for a long time. Historically, security teams were not adopting the same tooling that kind of developers did. So what we want to kind of show here that we can use Git to version control policies, share them with all of our company so they can see what we're trying to accomplish as security engineers, and they can provide the feedback, they can review it. They might want to introduce changes or exceptions and store them in a shared library. And then we want to validate things locally. So let's see how we can change the behavior that we saw initially. So what we're gonna do, we're gonna do something very bad that we should not be doing ever, but this is a demo repository, so that's okay. This, and in my repository, I have a pre-commit hook. Pre-commit hooks allow you to kind of run commands before you commit things into your Git repo. And in this pre-commit hook, what we're going to do, we're going to add a conf test call to pull the policy libraries that we have deployed into Gatekeeper from Git repository and execute them on our change. I'm just going to write this. So what we're going to do again, follow the same steps that we did before. Set this to privileged, which means our deployment, our pod will be running with privileges that we really shouldn't be giving to containers. Add it and try to commit it. And hopefully, if my demo guys are with me, and they are, what we can see here is we immediately get feedback, right? So we haven't committed anything into our Git history, and we have identified the exactly same problem that hopefully our demo was supposed to show us, but Git is not with us today. We would see that in order to bypass this step, we're just going to sync it manually, because that's the only thing that has changed. And as you can see here, that's the admission hook. It would usually take a long time, but as what we can see here, even our Git repository is taking way longer than 2-3 minutes that we used before. So this is how we moved from, let's time this here. So we moved from 4 minutes that the demo should really take to 1.4 seconds in order to get the same information to the developer about what they're doing wrong. So that's a huge improvement. But if you're not using Git hooks, and if you don't want to remember that you need to run these things locally, then you can implement the same checks in your PR settings. So we can quickly demonstrate the same here. And then we're going to do punch. And what we're going to do is ignore our pre-commit hook. And then if we look at our, oh, here we go. It took 12 minutes this time, but that's great. We finally get it to finish. Thank you, GitHub. And right, let's create a PR. And then what we should see here in a second, we have our validation. And because I know, let's hope it's going to be faster this time. Right, as we can see here, our pipeline is telling us the same thing, and it only took 7 seconds. So still improvement. And with PR checks, when they version controlled and they need approval to change, you can ensure that you get the same kind of security practices back early on to your developers. So that's 7 seconds. And then what you want to do is to make sure that your gates are automatically deployed to your kind of enforcement system, your gatekeeper. So for that reason, what we can demo very quickly is, in my library, I have introduced, we're gonna add another control. And then I need to do this. Yes. All right. Prevent. Do that in production. And what we should see in our Argo CD, and if you look at applications, that this should pick up the changes. Yep. So you can see here, our gate would pick up the changes magically. Now, I need to do it twice because I have a bug in Argo CD that I haven't figured out how to fix yet. So what we need to do is do this first. Synchronize. And now, in our command, what we're going to do is try to immediately make the same change, right? So we're going to go to deployment, and we're going to say host network true, which means we're going to have access to all of the networks of the node. And then we're going to try to commit that. Hopefully, as you can see here, and what's happening here? No, this is not what we want to do. So I'm going to make a trick. Demo gods do not like me today. Right. So what you can see here is we pushed it to central repository. We added additional check that is immediately enforced on the kind of gatekeeper level. But our developer, when they add new topic, immediately sees that the same check is enforced, and they get the feedback. They know they need to make a change. They know they need to do something in order to get that through the pipeline. So that's what you want to do. So what about our kind of cloud configuration? Can we use the same tool to help us with securing Terraform, for example, or CloudFormation? The answer is yes. As long as the data is structured, you can do it with Open Policy Agent, and this is an example of where we verify that security groups are secured. And then lastly, summary. So make sure you manage your policies as code. As we saw, just commit them to the central repository, manage them the same way like you would do your web applications, deploy policies automatically. So as we saw with the gatekeeper, the policies was enforced in the cluster, and then validate code early on. Let developers get the feedback early so that they can make changes in the local environment. They don't have to wait like we did 12 minutes for a pipeline that took way too long to finish in order to make changes and fix potential misconfigurations. And what next? If you're interested in the Open Policy Agent, here is the kind of awesome set of kind of resources that include everything from policy libraries, where you can just get all of that security policy content kind of prepared for you, so you don't have to start from scratch. The resources on how to use Open Policy Agent, SDKs, and whatever you could come up in your mind. And that's it for my presentation. If there's any questions, I will take them. I think we're running a little bit late because of the demo.
Yeah, good. Yeah, great. Thank you very much for your presentation and a live demo. By the way, yeah, it was nice. It was really nice. Yeah, Git likes you today.
I haven't prayed enough, so live demos are great, but as you see, we need to pray a lot to get them working.
Yeah, that's true. But nevertheless, it was really interesting to see these checks that we can do in order to save someone's life. Yeah. Okay. Good. So basically, yeah, that's. I forget to mention that after each presentation, we will have time, like 5 minutes, about 5 minutes for a Q&A session. So if you have questions, you can ask it in the chat, and we will highlight it here. Like the first question, it's basically my question, because I'm also part of the audience and I would like to know something. So why Rigo? Not any other language, Python or Go? And what are the pros and cons of using it?
That is an awesome question. We get that question a lot. Rigo was designed to kind of to solve a specific problem, to query a kind of large set of data structures very fast and in a kind of fail-safe manner, right? So we cannot, you basically cannot shoot yourself in the foot because you kind of limited of what you can do. But that's done on purpose. You also don't have to worry about thinking, is my code efficient? Is my code definitely written in a correct way that will use the right sorting algorithms? Is it searching? Is it looping way too many times, right? The kind of you want to the creators of the language abstracted that to compilers, to the runtime, to ensure that it is effective. So you can focus on making your policies very declarative. Write them in a way that they can be readable by anybody, and also by anybody that might not be developer. People who maintain policies such as standards might not necessarily be developers. And they might not have skills such as yourselves with writing Go or Python or any programming language, and teaching them kind of limited constructs of OPA may be simpler and may be kind of shared with wider audience than just developers who then have, high background in, running code such as Go or Python. So that's a primary reason why would you want to select something like Rigo.
Is it difficult to study, to start coding with Rigo?
I like to say it depends. If you are a developer and you have spent many years coding in normal imperative language, it will take your brain a little bit time to adjust. So because it's constructed in a kind of different ways, the way you normally think about a code might lead you into thinking you know what you're doing, whereas you actually kind of, it's not how the language works. So, but if you are not a developer, then there is a lot of resources that are out there. The explanations are quite clear and you can get into the groove. But even I fall into that trap of thinking, oh, this looks somehow like Go, so I can just do it. And then it took me many nights of thinking, why is Rigo doing it in this way than the other way? So there is pros and cons.
Yeah, okay, I see. Because I've never heard about this Rigo language, really. It was something new for me. So,
I would say it's a niche language. I don't like, because you cannot write a web application in Rego. Okay, it is only limited to querying data sets for information that you want to find. So it's not what I expect everybody to be familiar with. That's my take on this.
Okay. Yeah, I see. Okay, and the next question regarding the security, this step protection. Can a tool such as static application security testing with SonarQube Developer Edition increase product protection?
Yeah, it's a good question. Any security tool that allows you to discover kind of security misconfiguration early will increase product protection, right? It will. However, there is a high cost sometimes you have to pay to it, right? So the SAST ecosystem of tools have been very bad in the past years on generating too much noise, noise to kind of positive results ratio, right? So if you are flooded with 1,000 issues, out of which maybe 2 or 3 are something that you really need to make secure and protected, then I would say the SAST tool at that point is counterproductive, right? Because you are putting effort in filtering out noise rather than finding issues. So it really depends if the tool is actually delivering on its promise of finding misconfiguration or security issues, whether they vulnerabilities, versus finding just potential things. So it's an if answer again, but hopefully there are products out there that are trying to think about creating things, providing less but more accurate results and not focusing on numbers.
Okay, I see. Okay, yeah, that's 2 questions. Basically, we can ask one more question, and one pops up in my mind. It's regarding how do you manage the exceptions?
Good question. So for everything, so sometimes some things might be misconfiguration. So the example we had in the topic was kind of having privileged containers. Generally, it's a bad practice. However, you will find applications that require that permission. Right? They will not operate without it. Right? So we need to be able to say, for this specific time, that's acceptable. So what you want to do is come up with the system that allows you to manage them centrally. So always in code. So the same way I showed you my library of policies, you would, for example, want to have an exception list in there. That is managed as code. So for example, you as a developer would raise a PR saying for this rule, that's an exception. So we're not disabling the check. We're not saying that is invalid. We're only saying that we accept the risk. We accept that this is a elevated privileges, but we require it for our operation. So you're kind of accepting it and it's there, so we can move on. So manage them as code, make them visible to everybody in your company so they can be shared and distributed. And that's it. And Rego is very good at that. It allows you to kind of implement that in code and have various layers of exceptions for different developers.
Okay, I see. Okay, good, great. Thank you for your presentation. Yeah, it was really nice to see you and to see the live demo, because we do not I don't remember the last time when we do a live demo, but it was fun to see it. And yeah.
I love to watch me fail on the demos, so I'm never gonna stop doing them, but I like them too.
Yeah, live demo is always very hard work, and but something always can happen. Yeah, but it's okay. But that's fine. So yeah, okay. So thank you very much. Let's say goodbye to you.
Perfect. Thank you for having me.
Our next. Yeah.
See you guys next time.
Yeah. Okay. So let's invite our next speaker. It's Dmitry. Dmitry, hello. How are you?
Hi guys. I'm fine, and you? So I would like to test my sound. Do you hear me well?
Yeah, everything is fine. I can hear you well. Everything is correct. Yeah. So, how do you do? Good.
It's a bit late. Yeah. So it's Friday.
That's Friday. Everybody's dreaming sitting somewhere, relaxing, chilling after the work. Yeah. But today we have a great speakers and a great time to learn something new. So. Okay, I don't want to wait any longer. So let's start. Just can you share your screen and we'll go.
Okay, 1 second. And
by the way, I want to remind you, guys who is watching us, that you have a great possibility to ask your questions and to find to find the answers on your questions. Ask our speakers. So I think that that's a great possibility to do it. So okay, I see your presentation. Yeah, shift left with Snyk. Yeah. By the way, our first speaker was working in Snyk, so today we have a combo. Yeah.
Yeah, it's really funny.
Yeah. Go on.
Okay, I will start. So it's really funny to see Camille on the line. So yeah, actually, I will talk about this product. It's kind of overview, so I don't want to write the code and maybe run some kind of demo sessions, but still I wanted to explain how Snyk work and what how SAST help us as organization, how we can increase our security level by it.
Okay.
So let's start. So I wanted to introduce myself. Actually, security is my new profile. So I started working with security only this year, and before I worked as cloud engineer. So I mostly on startup environment. So I helped to spin up cloud and DevOps processes on different startup like Empada.doc, Target Process, Flow Health, WorkFusion, and Netform. And this year, I decided to change my focus and start working with DevSecOps approach and cloud security in the cloud security field. So let's talk about our company. So Flow is a startup. We number one on health and fitness applications. It's kind of iOS and Android application. So we have a huge amount of audience. So it's about 12% of women in US using Flow. So we have a bunch of money, as you can see, and quite good ratings on App Store. So we constantly deliver value. So we run AI machine learning under the hood and use it for predictions. Also, we make advice to women how to get healthy and how to get pregnant, and 2.7 million women get pregnant with Flow Health. And if we're talking about product internal, so it's follow super app strategy. So we have a kind of tracker possibility. We have a content library. So it's drive courses, events, and so on. Also, we have health assistants. So it's a chatbot. You can reach out our medical experts to help with any problems, and also you can communicate with other persons and other women about your with secret chats. Yeah. So let's talk a bit about cloud security, how it's actually default, how it's look like from a landscape perspective. Yeah. So we're using Amazon as our cloud provider. So in Amazon, it's quite straightforward security tooling. Yeah. So at first, it's kind of central place to collect all the information about compliance of environment called Security Hub. Also, Amazon have a Guard Duty. Guard Duty is a cloud-related CM tool. So it's monitor all the event, and if something going wrong and something, for example, some users trying to access non-existing API, or maybe some tools wanted to open wrong ports. Yeah, so we can have alerts with Guard Duty. Inspector is mostly malware detection tool, so it's agent-based, so we can install agent to each machines and run it constantly to find some kind of malware, viruses, and so on. Messi, it's all about data, so Messi can scan S3 buckets and find PI data here and help us to understand what's the data stored in our lots of S3 buckets here. And also AWS config. So this is kind of services which collect all the state of the services and collect all changes here. Yeah. So if something changed in our AWS environment, this change will attract an AWS config. So yeah, so if you're talking about separation of layers, so customer data can be scanned by Messi. Platform applications and access management can be scanned by expector, guard duty, and config. The same way as operation system layer, it's EC2 internals can be scanned by inspector, and all client-side encryptions go through the config. And all of these changes monitored by central place called Security Hub. Yeah, so let's talk about how security operations look like in AWS world. So, for example, we have imagine team wanted to create new instances, and it's really hard task for them, and they wanted to debug a bit this machine and wanted to open SSH port, and VPN is not the way, So the teams decided to open SSH to whole internet, and actually it's a security breach, just because in the internet we have a lot of crawlers scan all AWS API constantly, So if we have such breach, in a time we will have a problems here, So how it look like in the operational model on AWS? So config records these changes, and Security Hub analyze, is it compliant changed or not? If this change not compliant, so guard duty can send signal via SNS topic to our incident management tool. So we're using Opsgenie as incident management, and incident management have a kind of rotation mechanism, and incident response team receive a kind of signals about it. So we receive notification. So, okay, guys, you have a problem now, So you need to fix it. If you're talking about AWS Security Hub itself, the check I provide is only about ports, but they have a bunch of it, So they covered this framework. So it's common internet security framework. So in this case, we have a lot of controls, and these controls monitor and checked across all of the environment. So there are some kind of best practices and critical. So in critical part of systems need to be compliant. For example, we need to avoid using a root account, or not allow to attach access key to root account and so on. In this case, AWS constantly monitor it and present kind of report. So and if someone wanted to change this resource, and AWS Security Hub became uncompliant, security team will receive a notification and need to fix it. Also, AWS have a foundational security best practices. It's extended version of security rules and best practices. So it's kind of advisory, and it's not mandatory, but still it's kind of good practice to follow this recommendation in AWS world. So for example, not create RDS public snapshots, not to steal data, and so on. So these instruments also help us to measure security. So it's really hard to improve something if you can't measure it. So if we have some numbers, we can work on security and see our progress with kind of exact numbers. So it's funny things, and also it's understandable by management, by teams, by everyone. Every people don't even familiar with security. So for example, if we share this information, they can decide, okay, it's more or less okay. But if it's 20% of security score, it's not okay. So we need to do something about it. But what's the problem we have here? So in this model, all security operations kind of reactive one. So we just sit and waiting until we have kind of notification in our telephone, on our Slack. So, and in this case, we need to go to Teams and say, okay, guys, you provide a necessary non-compliant change, you need to revert it back. And it's always a painful process, just because in this case, all changes already in production, and managers expect the results. So everybody want to deliver value, and if you say as the teams you need to roll back these changes, it's a huge amount of pushbacks in this case. And also I wanted to share a bit of our way to work. So how we work with our environment. So we follow the DevOps conceptions. So each team can provide infrastructure changes by themselves. So we have a central repository, but it's not a one central repository. We started with one, but for now we have about 20 repositories here for different accounts in our organization. So in this repository, team can commit their code. And for example, if team needs to set up new services, they need to create maybe S3 buckets, some RDS instances, some users and AIM roles and so on. And we don't have a kind of bottleneck with cloud team, just because cloud only create a modules to improve the speed and how to say streamline this process, but teams need to provide this change by themselves. So some teams have a kind of good understanding about security, some teams not, and some teams not wanted to, I would say, reduce the amount of work, and in this case we can have a lot of security issues. So when we work previous year, we focused on increasing this security level of our organization, and this year we think about how to save this one. Yeah, so just because if we have a lot of changes, yeah, and for now we have about dozens changes in our AWS setup every day. Yeah, so there are not so many ways to prevent this, how to say, unnecessary changes. So first of all, it's kind of manual approach when security need to review and approve all the changes, but it's kind of, it will block our compliance. But also it can go to automated way. And in this case, Snyk really help us, just because Snyk, for now, Snyk is kind of passionate organization and drive shift left approach about security. So what does shift left mean? So as for now, we have a kind of two stream of changes. At first, the developers shifting right. So developers became more and more closer to production. So previously, developer think about only code and comment, yeah, and everything else, it's kind of IT stuff, yeah. So they provide code and provide artifacts to some cloud team or IT teams, and these teams install it to production, monitor how it work, and so on, yeah. But for now, developers who work with pipelines, with CI/CD process, and with monitoring tools by themselves, and understand what's happening in production. The same way, security start from right, yeah. So as I say, security can control and can receive notifications only after all changes actually installed in production. It's really bad way to, I would say, prevent these changes. So while developers shifting right, security is wanted to shift it left and trying to monitor and maybe prevent the change before it even merged in master. Yeah. So we start thinking about some kind of SaaS tools for our CI/CD pipeline and have a kind of review. So as for now, we have a kind of open source solution. So Chekhov, Terrascan, TFSec, it's great tools. So you can use it in your pipelines, and Snyk also can be used in pipelines just because Snyk have two modes. Snyk CLI, it can be easily installed to pipelines, and also Snyk can be run via UI. Yeah. But we don't want to focus only kind of SaaS capabilities, only kind of report things, but we also wanted to focus on rules life management. So we wanted to increase our security posture in Amazon. So it's crucial for us that we can easily control and adapt our security policy. So how security policies looks in Snyk? So in Snyk, for each services, you have a kind of profile, and you can mark all changes, so kind of all pillars by some kind of severity. Yeah. So for example, if someone wanted to create an encrypted S3 bucket, by default in Snyk, it's kind of severity medium. But if you want to be compliant with ISO, and you have a kind of production and user data inside this S3 bucket, you really wanted to increase severity of these changes and to make it maybe a critical one. Yeah. The same way, you can control all the other pillars. For example, EIM, you can tune up what the password policies look like in your organization. And the same way, you can control overall AWS settings. Yeah. So also good things. That's from these years, Snyk have also Terraform providers. So you can just not click in it in UI, but also have a kind of Terraform integration with Snyk and do it automatically. So long story short, we start thinking about integration this SaaS tool in our pipelines and start working and start scanning our resources. Yeah. So first of all, our main goal is at first prevent unnecessary change in block pipeline if we have kind of blocking high or critical vulnerabilities. But before to do such kind of change, we need to understand the whole landscape of our code. Yeah. So we start working with Snyk in permissive mode. We just run reporting without any action. So we just collecting all the reports and to understand what's the kind of what's the situation we have in our code and gather statistics. Yeah, and firstly, we create a Terraform reports step in the pipeline and run it in parallel with this Terraform read. So it's actually good news and it's quite fast. Yeah, so we spend less than minutes to scan with Terraform, and this reporting step scan only diff of the our changes. So it's not scanned all the files here, but not only the files which will be changed on this pull request. Yeah. So when we gather statistics, we understand that we have not so much non-compliant changes, and we have only two databases can be accessible by from the out world. We'll fix it, and after it we review Snyk SA UI. So in this case, we can control how many tests run it. We can see how many high severity issues we have, and we can go deep inside any bugs and understand, for example, remediation efforts here. The same way, we have a weighted issue list, so we can understand what's the kind of cloud posture here. And if you're talking about UI, so I just create kind of GIF for you to understand how Snyk looks like internally. Yeah, so for real project, when we start working our infrastructure changes, we have such pictures. As you can see, it's a bit outdated. It's early beginning of this year, so for now we have a bit different one, but still, for example, we can dive in any section and understand what's the module we have, and if it's not kind of compliant, what's the remediation effort we can have, and what's to suggest for our developers. Okay, so we understand that we are ready to, when we fix our critical and high vulnerabilities, we are ready to implement blocking step in the pipeline. So in this case, we can use severity threshold. So severity threshold means that if some if some files in this pull request will have a changes that break our security policies, we just break the pipelines and stop it, and user cannot merge this pull request to master, and in this case they cannot merge and deploy it to production. So yeah, so as I say from my first slide, so one of the biggest obstacle with Snyk from the early beginning is the speed of scanning, just because when we start working with the Snyk and trying to analyze all of our Terraform repository is quite big. It's contained more than 500 files. So when we start working and scan full repository, it's take about 5 minutes. Yeah, but Snyk's doing a great job and increase performance. And for now, it's talking about 16 seconds. So we decided to move security full scan repository to each merging event. So when pull request merge to master, we run EC reporting full scan, and we see the full pictures of our repositories in this case. Yeah. So also it's good news when we have a CI/CD in the code. Yeah, so we can apply the same configuration for all Terraform repositories. So as for now, we have about 20 of repositories, and all of these repositories contain reporting and blocking checks. So we have the same level of infrastructure, how to say, policies for each of environments. Yeah. So long story short, what's the result we have? So in this presentation, I focus only Terraform parts, but we also use Snyk to check Helm changes. And as for now, we have a lot of deployment events each day. So we have about 15 deployments with Helm each day, and about 5 to 10 changes of AWS infrastructure with Terraform. Yeah. So, and for now, Snyk scan all of them. Yeah, and we run a breaking pipeline for Terraform and prevent unnecessary change. And we still have the same and more robust security score how we have before. And we don't how to say, we prevent all unnecessary change to our production. And without kind of manual effort from security teams. So we don't have a kind of blockers, and we don't need to review all the codes and all the pipelines, and Snyk do it for us. And from security perspective, all we need is just to adjust security policies and roll out it to Snyk to, how to say, to have it in all of our infrastructure repositories. That's it from me. Thank you for your attention, and I hope you have a kind of question, and I wanted to answer it.
Yeah, thank you, Dmitry, for your presentation, for your cool presentation. Thank you. And yeah, we have some questions here regarding the Snyk. By the way, the funny question about the Snyk, like, how does Snyk handle your data? Where, like, especially in Floor, we are very critical to the data. It's very sensitive, and we know we need to store it, we need to protect it. So how does it work with Snyk?
Thank you for this question. Yes, so if you're talking about data, so Snyk is static analysis. So it's a SAST running inside the code repository. So this CI/CD pipeline doesn't have any kind of connection to the data. So Snyks actually don't handle our data. So Snyk handle our configuration. So Snyk prevent any misconfiguration change. But Snyk also secure our data. For example, if someone wanted to create database open to the world or S3 bucket without encryption, Snyk prevents these changes. So it's not, how to say, it's not handle data, but helps to make it secure.
Okay. And the second question, am I understood correct, and that this tool from the box can find and automatically fix vulnerabilities in my code? Open source dependencies, containers, and infrastructure is code, all powered by Snyk.
Thank you for the question. Yes, Snyk have a possibility to fix your code. Yeah, so you can create automatic PIR. So if you have any issues in your dependencies, for example, you have outdated version of Docker or maybe of your dependencies, Snyk have a possibility to fix it with CLI. So Snyk CLI also it's a new feature for Snyk CLI to fix your kind of code. And also you can do it with your UI. So you can create a pull request, and Snyk can apply your Snyk can create a pull request with bumping of necessary changes. Yeah. But it's really good practice to review these changes and apply it manually and, how to say, roll out it gracefully, just because, it's not a good idea to run Snyk in production and fix it automatically without any kind of approvals and other workflows.
By the way, do Snyk supports different systems like GitHub, Bitbucket, GitLab? Yes, Snyk have a different integration. So I focus on the packages because we use Bitbucket in our organization, but Snyk also have a connection with GitLab, GitHub, and so on. And also I focus only on AWS environment, but Snyk also have a GCP and Azure integration. So you can also do it. And what about the subscription or the license? This tool is not for free, I think, right?
Yeah, of course.
So it has so many possibilities. It offers so many possibilities, and I think that it costs some money. Or what range do we talk about?
It's hardly depend on your organization. So we have a lot of developers, so we pay a lot of money. But for smaller organization, yes. So if you have maybe 5 to 10 persons, it's not kind of a huge amount of money. And also, Snyk have free subscriptions, so you can run Snyk for free, just for limited kind of amount of features.
Okay, I see. And as I know, Snyk also is possible, like you can integrate Snyk in pipelines for a mobile process and and not only for backend, right? So it works for, it doesn't matter like what is it. I mean, it scans dependencies no matter what is it, right?
Yeah. So in this presentation, I focus only on Snyk AAC. So it's Snyk for Terraform and Snyk for Helm. But yeah, so Snyk also have a dependency check, and it can check dependency of whatever language you use, for Python, for Scala, Kotlin, and so on. The same way, Snyk also have a new product called Snyk Code, and this product can actually scan security level of your code. So it's not support all the language at the moment, but it's a new product, and we'll see how it's performed next year.
Oh, by the way, Camille said that you can get around 300 scans a month for free to get a feel for. Okay, I see. Yeah, that's a nice tool, I think, and I hope that we hope to answer some questions and cover a lot. So yeah, there is no more questions as I see in our chat. Basically, it means that I think that we can finish our stream today, our meetup. Thank you, Dmitry, for coming, for joining us, and for telling so many interesting things. I think that a lot of people. I think that today is Friday, and you can you can have a rest. So yeah.
Okay, thank you, guys.
Okay.
Have a nice weekend. Bye.
Yeah, thank you, Dmitry, and I want to say everyone, thank you very much. I want to finish just with one small thing, like I want to remind you about our feedback form that you can fill in, and it will really help us to go forward. And today I want to finish. Thank you very much. Thank you, everyone. Thank you very much for joining us. So see you next month.